now recording. Share screen, sharing screen. And let's just go through these questions of what to do. So for number 5, know how decibels and loudness are related. So you could just obviously look at your notes. Obviously, if you go to your notes, let me close these down. Let me close that one. Open this one. Yeah, so if you look at like sound intensity, that's probably where you want to look at the notes 7.4. And they kind of talk about how those are related. 6, know what affects speed of a wave, frequency, wavelength. That's pretty easy. So just have that discussion or just know that stuff when you guys are meeting with your breakout rooms. 12, 13, 14, remember the formula is just this. V equals the frequency times wavelength. Remember, frequency is 1 over your period. Periods, I'll use capital T. So that should be pretty straightforward for 12 and 13. For 14, you're asked to find the amplitude. That's just the height of the wave. Kind of already gave that to you right there. The wavelength is the length of one wave or one cycle. There's one cycle. Easy peasy. And then you should be able to get the frequency if you know the speed. Frequency is actually how many cycles you get per second. Might be easier just to use the formulas for that. 15, so you send out a sound, and then you hear the echo 20 seconds later. So think about it's traveling the wall or traveling to some location and then coming back to you. So it's actually double the distance. And you have the speed there, so you'll work that out. 17, the formula for that is right here. There's your formula right there, that one. For 18 and 19, the formula is right there for Doppler effect. Remember, if the source is coming towards you, as is the case for so that's going away from you because the car is passed. 19 is going towards you. So 18, if it's going if it's past you, then you want to use a bottom sign. So you want to do VW minus VO and then VW plus VS for number 18. For number 19, because it's going towards you, so the frequency is going to get more intense, you do VW plus VO and then VW minus VS. So you guys work that. You have all the worked out answers there. For circuits, yeah, I mean, know what current, resistance, resistivity, potential difference, know all that stuff. An ammeter measures current, voltmeter measures volts, easy. The rest are all computations, starting number 5. Remember V equals IR, that's kind of the big one. But I is also going to be your charge, which we call Q, over time. And the time is always going to be in seconds, just so you know. The charge is given to you in coulombs, which I'm probably butchering the spelling and butchering my handwriting as well. And I is always in amperes. But essentially, it's a coulomb per second, or C is what we do for short, for a coulomb per second. Yeah, 6 is easy. V equals IR. We know this. For resistivity, we have a formula for that. That's right here. That capital R equals little p. Sometimes we call that rho as a Greek alphabet, times capital L, the length of the wire, divided by A, the cross-sectional area of the wire. Yeah, 8, if you're looking for energy, you can take the power and multiply by time. That will get you energy. So you have the time, so you just do P equals IV. And if you don't have V, remember V equals IR. So you just substitute. That's I squared R. And let's get the power multiplied by the time because the power is in watts. It's a power formula again, it should be easy. 11 when you're in series, you're adding up, that's just great. Hold on, let's do that. Yeah. So series right there, add them all up. Parallelly do 1 over. So that should be pretty easy for 11 and 13. 12, of course, find the total resistance, that series, and then get the current. And then 14 is calculating total resistance. So it's a lot of problems, but you guys can do it. So that's 4. This looks like 9 computation problems and 2 for you guys to discuss here. And then here it looks like it's 1, 2, 3, 4, 7 computations and 2 to discuss. So we'll do this as a pretty long breakout session. We'll do this as about 40 minutes to kind of go through all those in your groups. Call me over if you have questions. If you guys just want to talk about your strategy for tomorrow, how you're going to go about the lab simulation, or go back and do some lab simulations, you can do that as well. So this is your chance to kind of just, one last chance. Well, you guys can always meet tonight if you want, or early tomorrow morning. You guys can reach out to each other. But just in the structure, this is kind of our opportunity for you guys to just talk stuff out, work through these problems, figure out your strategy for the lab simulations, and of course to help yourself for the individual multiple choice assessment in the afternoon tomorrow. And again, remember, we're starting at 10:15. I'll be online at 10, but we're starting at 10:15 sharp. So that's when I'll email the simulations to you guys, the simulations you'll do to each individual group with the questions for each of those simulations. And then you'll have till 11:45 to get that done. We'll have a lunch break, remember, from 11:45 to 12:30. And then the plan is to do 12:30 to 2, but I'll be flexible. If you don't turn by 2, that's fine. Turn at 2:30, 3 o'clock, I don't care. Especially with extra time, that's fine too. But I will ask you to upload your work for the multiple choice so I can give you some partial credit if you happen to miss any questions. Yeah, then you're done with physics. We're almost there. We're pretty much 24 hours away from having the summer class done. And you guys are doing great. I sent in individual grades. If your individual grades are a little bit low, it's probably because you're missing some work. So I would strongly advise that you get that done, turn it in so you can help yourself, right? I'm pretty flexible with helping you with, or for, accepting work that might be a bit delinquent. I'm probably one of the more forgiving teachers when it comes to that. So yeah, I'm here to help you guys out. So clear, stop. And you caught me saying I'm recording as well. So I'll hold myself true to that. All right.